Welcome, dear friends of protection control and electrical engineering. According to legend, the remanence of a current transformer can be eliminated by hitting the transformer hard with a hammer. We want to know what's behind this narrative and doing the practical test today. Therefore, the disclaimer right in advance. Please don't do that at the customer site. We are conducting an experiment here and the general rule applies with the force of a law: CTs are not beaten. Here we go. The story behind the narrative is simple. Wise domains in the iron core represent polarized domains which, after a heavily shifted short-circuit current with a high direct current element, drive the CT to a remanent magnetic operating point. Since we generally don't like remanence that much, the question arises as how to demagnetize a core. Legend has it that you only have to hit the CT hard enough to demagnetize the core, since the elementary magnets align themselves in any direction and the wise domains are neutralized. We will see if that really is the case in our hands-on test today. For this purpose, we give several short-circuit current pulses to our CT core in order to drive it really saturated. We wound a 100 to 1 amps 5P20 protective core, which was measured with a remanence factor of 95% 20 times, and now feed in 50 amps DC several times for a short period with our Sverker 900 from Mega. So in sum, we feed in 1 kiloamp direct current, way enough to send this guy into nirvana. To check the remanence, we carry out a measurement with the Austrian Wunderkind, the CT analyzer from Omicron, and measure a remanence of 86%. Now we have to magnetize the CT again, since the CT analyzer automatically performed a demagnetization at the end of the measurement. To do this, we feed in some DC impulses again with the Sverker 900 and can start with our test. We hit the CT a few times with the rubber mallet and repeat the measurement with the Austrian Wunderkind. We measure 86% again, the same value as before our special mechanical treatment. This makes it clear our current transformers don't have to be afraid of hammers in the future. But one big question still remains. How can we eliminate the remanence of a CT in practice? As we have already seen, our CT measuring devices automatically carry out demagnetizing measures at the end of the measurement. In practice, the CT core can be easily demagnetized with a magnetization characteristic recorded backwards, coming from the knee point voltage in the direction of 0 volts. Let's take a final look at this. After we magnetized the core again with direct current, we run an automated measurement with the Sverker 900 to determine the knee point voltage. Once at the top, the Sverker 900 easily lowers the voltage back to 0, and another check with the CT analyzer aka Austrian Wunderkind shows that the core has been completely demagnetized, and with that we come to our conclusion. CTs can't be demagnetized with a rubber mallet. While we don't know what would have happened if we had used a sledgehammer, we want the CT to stay whole. A demagnetized CT that is in front of us in several individual parts doesn't make that much sense. We are pleased that we were able to clear up this fairy tale today, that the CT has survived our treatment and that we can continue to do our work peaceful in the future. With this in mind, warm wishes, thank you for watching and see you soon.